Okay. Okay. So I will be putting the materials on the left side as well as the uh blank sheet on the right side, so that if let's say I want to write something, it is there. Okay. So is it okay for you? Can you see the materials, the slide on your left side? Is it clear?
Yes.
Or you want me to make it bigger, like a normal slide? The same, right? What is yes, Diana? Is it normal slide or normal shape or side by side?
Side by side
Side
is
by
okay,
side.
madam.
Oh, okay, that's good. Okay, so this is chapter 5. Please let me know if I'm going too fast, okay? Because sometimes I may not realize it. Okay, chapter 5, what is it? Well, they didn't put the title. Is about hypothesis testing. Have you heard about this term?
Yes.
Yes, this is something familiar to you. So basically, I don't really have to explain this topic to you because you already know this from your first year course. Okay? But then, well, it's a good revision if let's say we look at this topic. Okay, remember econometry is all about uh, economic theory, and metric you wanna test the theory using some quantitative data, and one of them is actually using hypothesis testing. You want to test your hypothesis. What is hypothesis? Hypothesis is like your assumption. You want to test your assumption whether it is true or not true, whether it is correct or not correct. Okay. So hypothesis testing and statistical inference allow us to actually answer questions about the real world from a sample. So remember, you have your population. This is your population, and it's almost impossible for you to study the whole population. What you're gonna do is that you select a sample. So from this sample, you will do hypothesis testing to check the characteristic to make sure that to actually describe the characteristic of your population. Okay. If let's say you are studying the whole population, you don't really need the hypothesis testing. You are using hypothesis testing because you want to infer, you want to estimate the characteristics of your population. Okay, so of course, a hypothesis testing is used in variety of setting, variety of way. So you can actually test food and drug product testing. Well, of course, if you want to come up with the food, if you're gonna come up with a new product with a new drug, you have to test, right? If you don't test, people will be pass away because your product is not tested properly. So you need a hypothesis testing. And then you can also test theories of Keynes. You can also test all your economic theory. Okay. Sometimes people will think that you are conducting hypothesis testing because you want to check whether your theory is correct or not. Not necessarily. Uh, okay. So if you can see this next point, it's almost impossible to prove a theory is correct or not with the hypothesis testing. So basically, hypothesis testing is only state that a particular sample confirm to a particular hypothesis. You are not testing whether your theory is correct or not. You are just checking whether your based on your sample is actually confirmed with the theory of economics. Okay? Okay, don't confuse with that. Next. The first step in hypothesis testing is to state the hypothesis. So you have a plural here. Why is that? You're going to have H null and H1. You're going to have null hypothesis, or what we put it here, you're going to have H null and H1. Sometimes people put HA, alternate hypothesis. So both are okay, both are fine. Okay, so hypothesis testing should be done before your equation is estimated. Sometimes people collected the data and then they run in the EViews and then they got the result. After they got the result, then they will do hypothesis testing. No, hypothesis testing should be done before you want to estimate your equation. So you have to have your priority expectation. Remember, if let's say you have the variable, what is the impacts of your independent variable to dependent? Is it positive or negative? So you should do it before you estimate your equation. So you have to hypothesis, H null and HA. Okay, you can say alternate, you can say alternative hypothesis. Okay, so normally H naught is the general claim. Well, you have learned this in statistics, right? General claim is like a normal assumption, like people can assume so many things. Okay, and it may be right, it may not be right. So alternative hypothesis or HA, H1 is your own hypothesis. So you want to say that, well, basically the null hypothesis is not correct. So you come up with your own hypothesis. So basically alternative hypothesis is your own hypothesis against the general claim. Okay. So how you want to write the hypothesis normally? You're going to write your H1 first or HA first because this is your own hypothesis. And then you're going to write H now. Okay. Okay, and see, example. If you expect a positive coefficient, okay, positive coefficient. So this is your expectation. This is your hypothesis. So your HA, your beta is bigger than 0. Is positive. So how you want to write H null? H null should be the opposites of your sign. Your sign is bigger. So H null should be smaller and it should contain equal sign. Okay, if you expect negative, so this is your hypothesis HA. So beta is smaller than 0, and your H null should be the opposite of smaller, which is bigger, and should contain equal sign. Okay, this is the case of one-sided test. Why is this one side? Because it is smaller. Smaller means, well, this is, you have learned this before, right? Okay, if you want to draw a diagram, smaller mean you are looking at the tail on the left side. If you are talking about bigger, you are looking at the tail on the right side. So basically, one-sided test means that you are just looking at a particular tail or this particular tail. But when you are talking about two-sided test, basically you are looking at the tail simultaneously. Okay, that's why they call it two-sided test. Okay, and how does it look like? Of course, your H1 or HA will be beta. What is it? What is the sign for two-sided test? Beta not equals to 0. Remember, H null, this is the rule of thumb, which you should remember. For the H null, it should contain equal sign. It could be equal, it could be smaller or equal, it could be bigger or equal. But H1 or H null, you cannot have equal sign. It can be, let me put here, this one H1, HA, right? It can be lesser, bigger, or not equal. Okay, so you have to remember the rule of thumb. Next, this is two-sided test or two-tail test. Okay, I mentioned about the tail, but I didn't say that two-tail test. Remember, when you want to look at the the tail simultaneously. Okay, so this is how it look like. Okay, except in unusual cases, which you should, I don't think we have to look at the unusual cases. Normally, economists always put what they expect in the alternative hypothesis. Normally, your hypothesis is HA or H1. This is your hypothesis. Okay, a normal cases. Okay, unless you have a different, unless you are certain that the null is actually the right one. The general hypothesis is the correct one, but it is less likely. Normally, the general claim are not correct, and we want to come up with our claim saying that no, the result is not that. We want to come up with our own result. Okay, so typical testing technique in econometric. Okay. Okay, first you have to hypothesize the expected sign for each regression coefficient. So of course, when you have your equation, you have to somehow have the priori expected sign. You want to expect negative or positive on the dependent variable. And then you want to determine whether to reject the null hypothesis. So you have to remember you will always want to reject the null hypothesis. Why? Because null hypothesis or H null is the general claim. Don't reject HA. HA is your own hypothesis. Okay? It is unrealistic to think conclusion from regression analysis will always be right. Why it is not realistic to think that the conclusion that you get from your estimation is always right? Of course, remember, you are actually testing your sample. Okay, sometimes your sample may not be representative of your population. For example, you are talking about populations of IIUM in Gombak. But then you take the sample from Kuliah of Economics. Do you think that Kuliah of Economics is a good sample for the population? Is a good representative of IUM students in Gombak? No, not necessarily. So your result might be not correct. So you cannot think that the conclusion that you get from regression will always be right. It sometimes can be wrong as well because we are studying, we are analyzing the sample. Okay? There are two types of error here. Remember, we may tend to make an error, not error, one error, may tend to make some error. So the first one is type 1 error, type 2 error. I think you also have learned this in statistics. Well, basically I can just skip all this thing, right, and make it fast. But just for those who may not have seen this before, okay, some of you, I don't know, from different, well, but if you are studying in IUM from first year, you should have seen this. Okay, but it's okay. I'll just go slowly. So because some of you may forgot what you have learned before. So type 1 error, you reject the null hypothesis when the null hypothesis is actually true. Or it says that reject a true null hypothesis. Type 2 error, the null hypothesis is not true, but you do not reject it. Okay? So remember, type 1, you reject a true null hypothesis. Type 2, the null hypothesis is wrong, is false, but you do not reject it. If it is wrong, you have to reject it. Okay? So these are the error. Okay. So let's look at the example. Suppose the following null and alternative hypothesis. You have H null, HA. Okay, what is your HA? Normally, I will look at it at HA first, even though H null is on top, because HA is our own claim. HA, your beta should be bigger than 0, or whatever means that your beta is positive. Okay, H null should be the opposite and equal sign. Okay, now what is your HA? The defendant is guilty. Okay, you caught some, I don't know, criminal, and then you bring this criminal to the court, and then you wanna say that, okay, my assumption is that he is guilty, so he should be penalized. But then general claim, remember the rule of thumb in law, no one is guilty until it is proven guilty. Okay, so the general claim is that defendant is innocent, but you want to prove that he is guilty actually. Okay, so this is your own assumption or hypothesis. So case 1, you assume true beta is not positive, but researchers estimate lead to rejections of the null hypothesis. So this is what you call type 1 error. Okay, so basically, what is type 1 error? Anyone?
Rejecting a true null hypothesis.
Yes. So H null is true, but you reject it. Okay, so basically you send an innocent defendant to jail. Defendant is innocent, but you didn't reject it, so you send them to jail. Case 2. Okay, you assume true beta is positive. Okay, so if it is positive, you have to reject H null, right? Okay, but you do not reject the H null. It is positive, it is true, so you have to reject H null. So this is the case of type 2 error. Means that you free a guilty defendant. Okay, so this is just the examples of type 1 and type 2 error. So sometimes when we put beta, you cannot relate to the you cannot make sense of it. So that's why I put the examples of people to make it more sense. Okay, so next, so this is also the term that you have seen before, decision rule. So what is decision rule? Anyone still remember? It's a method if you want to decide whether to reject or not to reject your H noun. Okay, remember you always want to reject H noun. Don't reject your HA or H1. Okay. So a decision rule involves comparing. Of course, you have to compare your. They put here a sample statistic, but normally we're gonna say you wanna compare your test statistics with the critical value, or what we put here. Normally, critical value we will say CV. Where is the CV? CV. Okay. So you wanna compare your test statistic with the CV. Okay, test statistic or sample statistic can be not only just one. You may use T test, you may use F test, you may use chi-square. You have different type of test statistic. You may have many other things, right? Okay, decision rules should be formulated before you have to do it before regression estimates are obtained. Okay, you have to have the decision rule before you come up with your equation. Okay, so your CV is divided, of course, acceptance and rejection region. So if let's say I want to write it here, I think we already have the diagram. Okay, it's okay. So this is your diagram. Okay. Okay. So the middle is 0. Okay, perhaps your CV. Let's talk about one-sided test, one-tail test. So your CV is perhaps 2.5. So 2.5, this whole area is called as, what is it? Remember? This is what you call rejection region. Okay. So remember, you want to compare your CV critical value with the test statistic. So test stats could be many other tests. You can have T, you can have F, you can have Z, and other things. Okay? For example, your test statistics fall somewhere inside the rejection region. This is your T test. What will you say? You will say reject H null. But if let's say your T statistic or test statistic fall outside the rejection region, what will you say? Do not reject the H null. So I got a call. I have to respond to it. Just writing a message so that she will not disturb me. Depan rumah. Ayah. Okay. Give me about like 5 minutes. Ayo. I asked her to come early, but she came now. Okay. Hello, auntie. I have. Okay.
Tak senang.
Saya ada kelas. Satu sebentar. Give me 5 minutes. I'll get back to you, okay? Just 5 minutes. Okay. Sorry, everyone. I don't know why she came now. I told her to come tomorrow. Okay. Where am I? Can you guys hear my voice? Did I open my speaker? I did. Can you hear my voice?
Yes.
Yes, madam.
Oh, I forgot to hold the recording. Okay, it's okay. So let's see. Where are we? So this is the decision rule. Oh no, I opened my WhatsApp for so long, isn't it? Okay, so where am I just now? Okay, so have you cleared about this decision rule?
Yes.
Okay, so let's see the notes. A decision rule involves comparing your test statistic with your CV, right? Decision rule should be formulated, of course. I think I already covered this. Okay, next. So for a two-tailed test, two critical values are selected. Of course, if you are talking about two-tailed, the example that I have given to you, the CV. This is your CV. Your CV is just 2.5. This is actually one-sided test. Okay, one-tail test, which is positive. But if you have two-tail test, your CV will contain two values. So you have plus 2.5. You also have so let me put a different color. You're gonna have negative 2.5. So this rejection area will be two areas because you're talking about two-tail. Okay. So rejection region or area measures probability of a type 1 error if the null is true. Okay, so unfortunately, if you decrease the chance of type 1 error, it means that you are increasing the chance of type 2 error because they are related. If you reduce one, you are increasing the chance of having the second one. Okay, so this is the graph for the acceptance or rejection region. I think I already shared this, right? Okay, so this is the examples of one-sided test. So you can see that the shaded area or the region is on your right side, means that this is the positive, positive distribution. I mean, not distribution. Is it positive? Means that your beta is bigger than 0. That's why it is on the right side. Okay. And the second one, or the first one is also one-sided test or one-tail test. The second example is two-tail test. So you have two rejection region. Okay. So if let's say your test statistic fall under the rejection region, you have to reject the H null. So this is the first test, t-test. You have seen this, right? T-test is used to test hypotheses about individual slope coefficient. Okay, previously you haven't learned about coefficient, you haven't learned about the beta, but in econometric, you will be seeing the betas or coefficient. It is appropriate test when you're gonna use t-test when the stochastic error term is normally distributed. Okay, your error, your epsilon is normally distributed, the variance of the distribution must be estimated. Okay, since these two are usually the case, of course your error term should be normally distributed and you want to estimate your variance. The use of t-test for hypothesis testing has become standard in econometric. Okay, normally we're going to use t-test in econometric. Okay, so we can calculate t-value for each estimated coefficient. Okay, if you look at this regression equation, how many variables do you have? How many independent variables do you have? How many?
Two.
Two. Okay. So in this case, t statistic for the whatever variables, whatever coefficient you have, case coefficient. In this case, you have two coefficient. Okay. So the t statistic, this is the formula. You have beta hat, which is your estimated coefficient. K is whatever variables independent variables you are talking about, minus beta for H0 divided with standard error of the estimated beta. So your K could be 1 independent variable, 2, 3, and so on. Okay. So if you look at here, the beta hat, of course, the estimated regression coefficient. Beta H0, the border value of coefficient for the case variable, whatever variable. This is your standard error of the beta. Okay. Since most regression hypothesis test whether a particular regression coefficient is significantly different from 0. Normally we want to test whether it is different from 0 or not. So your beta for null hypothesis is normally 0. Okay, so you don't really have to put beta hat minus beta h now. What you're gonna do, because h now is 0. So to make it, to simplify the equation, what you're gonna write for your test statistic, beta hat minus 0 over standard error of the beta hat. But it's 0, you minus 0, so just ignore it. So you just put test statistic equals to beta hat over standard error of the beta. Well, this is just what we call the technical part of it. Okay. Let's look at the example. Do you still remember the case of Woody's restaurant from chapter 3? I think I have changed the Woody's restaurant into Mama restaurant because it is a 24 hours restaurant. You still remember? No?
I still remember.
After that, because you are eating too much kuih raya and lemang and ketupat, now you forgot. Okay. Luckily, you still remember. Okay. If you still remember, let me ask you about the independent variable. Okay. What is this Y? Y hat. Y hat is basically the estimated gross sale. Okay. You have the beta naught, the intercept. And then what is this N? If you still remember, if you claim you remember, what is this N? Okay. Huh. What is it, Idham? You want to say something?
No, madam. Trying to recall, madam.
Okay. So N is the number of competitor. So what you gonna expect? If you have higher number of competitor, what happened to the income? What happened to the sales of the Woody's restaurant?
Lower.
Yes.
Lower. So it's a negative relationship, right? And then you have P. What is this P?
Population.
Oh, that's great. Okay, so population. If you have higher population, what happened to the sales of the restaurant?
Positive.
Yes, yes, positive will be higher. Higher the population will be higher the sales of the restaurant. And what is this I? I is the income of the people. Okay. So what will you think about the prior expected sign? Higher the income of people, will it have a positive impact on the restaurant sale?
Yes, it depends.
Yeah, could be, right? If you are having higher purchasing power, you have higher income. So most likely you will just go to the restaurant and eat there. Okay, you don't really bother to cook for yourself or your family. Okay, so I just want to show to you, this is how you want to present your result. Okay, we are talking about cross-sectional data. So you can see that the gross cell or the cell has a small I. Small I tell you that we are talking about cross-sectional data. So you can see that every independent variable has a small I. And because you are estimating the equation, so your sales or your dependent variable has a head, Y hat, because you are estimating it. Okay, so you have to record it this way. Remember our question for the quiz? I asked you what else you want to include in the equation if you want to report your result. So you have to put I for cross-sectional, you have to put head, okay? And then below the independent variables, you have what is in the parenthesis, in the bracket? What is it? This is what you call standard error. This is the error that you make when you are trying to estimate the coefficients of your the estimated coefficient. And then below the standard error, you have to put the t statistics. So every independent variable going to have their standard error and t statistics. And then you're going to put how many numbers, how many sample You collected 33 observation and you want to report the R bar square as well. Okay. Now, um, hmm, hmm, okay. So this is how you wanna compute the test statistic. This formula is beta hat over standard error of the beta. Okay. Now you wanna find the test statistic or the T statistic for P, for population. Okay. So look at the small p. So you are not talking about N or I. You are talking about the population. So how to find the test statistic for population? The formula is beta hat over standard error. So what is the beta hat for P? Okay, if you can see my cursor, I cannot really highlight it because it is in equation. So 0.3547, this is the beta hat. Means that this is the estimated coefficient divided with its own standard error, which is 0.072. If you divided it, you will get the T statistics. Okay? Is it clear? Okay.
Yes.
Clear, madam.
So basically, if let's say I give you a question, I give you the coefficient, estimated coefficient, and the standard error. Okay, I ask you to compute the test statistic, T statistic. So you should know how to find it. Or I give you the T statistic and I give you the coefficient. I ask you to compute the standard error. You should know how to compute it. Okay? Okay, next. Whether to reject or not to reject the null hypothesis is based on, well, of course, you compare your T value with the CV. Okay, so critical T value is CV. Okay, so CV will somehow distinguish the rejection and acceptance region. Well, this is like a repetitive. I should actually delete this, right? Okay, so CV, basically they put TC. Is selected from a T table. Remember your statistics. How you want to find your CV, you have to look at your T table. So how your T tables look like? This is Z table, right? So your T table will be looking like this. If you still remember your T table. Okay, so let me put it here. I know that you already passed your statistic with the flying colors, but econometric is just an extension of statistics. So if you forgot your knowledge on statistics, please do some revision. Okay. Okay. So whether the test is one-sided or two-sided, of course. If you look at here, level of significance for one-sided means one tail test, two-sided is two tail test. Because if you are confusing between these two, you will get the wrong answer. They are different. Level of types, one error specified. Okay, normally they will inform to you. Degree of freedom. Why do you need this degree of freedom? But we write normally DF. So why do you need degree of freedom? Of course, because degree of freedom, which if you can see my cursor, will tell you which value are you going to pick. From this degree of freedom, then you will mesh with one tail or two tail test. If you don't know degree of freedom, you cannot find the CV value. Okay, so far so good. Okay, so once a CV has been selected and the calculated T test has been obtained, you can apply this decision rule. Reject hash null if your test statistic depends. In this case, T test is bigger than CV, and if your test statistic has the sign implied by your hypothesis. If let's say your hypothesis said that the sign should be positive. So if let's say it is positive, then you reject hash null. If let's say the sign is different, you cannot reject hash null. Okay? So let's see here. So this is the decision rule. Just an example for one-sided hypothesis or one-tail test. You can see that this is bigger or this is smaller. Okay? Two-sided, well, the same thing. Two-sided means that you have equals or not equal. Okay. Okay, okay, so the first example is one-sided hypothesis around zero. Normally we want to test whether whether the coefficient is bigger or smaller than zero or it is not equal than zero. But sometimes you also want to test your coefficient with other value. Sometimes you want to see whether the coefficient is bigger than 5, bigger than certain number. Okay, not necessarily 0. You can also test that using t-test. Okay, let's look at another example. Well, so this is one-sided test, one-tail test. What is this P? Coefficient for population. So you are expecting that if the higher the number of population, the higher the restaurant sale. So that's why you have a positive sign. You are expecting that this population will have a positive sign. Okay. There are 29 degrees of freedom. So how to actually compute degree of freedom? In statistic, you're gonna have n minus 1. But in econometric, you have n. Okay. This n refers to your sample size, your sample. Although in statistic, capital N refers to population, but actually in econometric, n is just your sample. So to find the degree of freedoms in econometric, you have your sample minus k. What is this k? This is the number of independent variable. At the moment, you have number of competitor, you have populations, you have what else? Income. So your independent variable is 3, and then you have to minus 1 as well. So your observation, your sample is 33, minus 3 independent variable, and minus 1. That's why your degree of freedom is 29. And you want to use 5% significance level. So let's try to find this CV, okay? This is one-sided test, one-tail test. What is the degree of freedom? 29. So let's look at your T-table. Look at degree of freedom. Go to number 29. 29 is here. Oh no. I wanna highlight 29. If you can see my 29, it's a very small there. Okay? So now, what is it? You are using 5% significant level. This is one side, one tail test. Okay? So, this is two tail test. Then look at this. Look at one tail test. And you are using 5%. Where is 5%? This one. Okay? One tail test, 5%. Okay, so go down to 29. You will get, where's 29? 1.699. So this is your CV. Is there any question on how to find your CV? Anyone is clear? Everyone? I think you have the recording, right? It should be fine. Okay, so this is your CV. Remember, CV is very important because you want to decide the rejection region. So reject H null if your T statistic is actually bigger than your CV. Okay, and if your T statistic is positive. What is your T statistic? You have computed it. Remember your formula? You have your your estimated coefficient divided with the standard error. So you got positive 4.88. Okay, remember the rule of thumb says that reject H naught if 4.88 bigger than 1.699. It is bigger, right? And the value is positive. It's follow your expected sign. Okay, since 4.88 is bigger and it is also positive, you have to reject H null. Okay. If I'm going too fast, you have to let me know, okay? Okay, the level of significance indicates the probability of observing an estimated t-value greater than the CV if the null hypothesis was correct. So what is this level of significance? So if you look at in the t-table, level of significance is actually represented by alpha. Okay, if you can see my cursor, I already highlighted the alpha. So level of significance, you can have one tail, you can have two tail. But when we talk about level of significance, we are referring to this alpha. Okay, it measures probability of type 1 error implied by a particular CV. Okay, how should you choose a level of significance? The example just now, you are taking 5% significance level. But how do you know which one you want to choose? Well, you can choose whatever. You can choose 10%, you can choose 5%, you can choose 20%, 2.5%, and so on. But normally, most beginning econometrician assume the lower level of significance, the better. Because if it can lower the chance of making mistake when you reject the null hypothesis. So normally for the econometrician, they love to take this 5%. Where is the 5%? What do you mean by alpha equals to 5%? What do you mean by level of significance is 5%? 5% means that your confidence interval is equals to 95%. Means that you are confident, your confidence, what should I say? Let me rephrase. You are 95% confidence that when you reject your H null, your result is correct. Okay? So 5% means that you are 95% confidence. But if you are talking about 10%, you are 90% confidence. Okay, but if you are so sure that your results are correct, you may want to use 0.01 or 1% alpha. 1% alpha means that you are 99% confidence that your result is correct. Okay, so next. Unfortunately, when you have a lower level of significance, when your alpha is low, it will increase the probability of type 2 error. Okay? Okay. So using so it says that normally people will be using 5% level of significance. This is like the safest way. If you are not sure about your result. If you can reject the null hypothesis at the 5% level of significance, it is common to summarize and say the coefficient is statistically significant at the 5% level. If you reject at the 10%, the coefficient is statistically significant at the 10% level. This is just how you want to interpret your result. Okay, so have you heard about p-value? Anyone? I think we have I already mentioned about p-value in the early class, right? Okay, p-value or marginal significance level is actually an alternative to the t-test. If you ask me which one you're going to use, t-test or p-value, my answer is very clear. I'm going to use p-value because if you estimate your result, by looking at the p-value, you know that these independent variables are significant in affecting the dependent variable. But if you look at the t-test, you don't know. If you want to know whether the variable is significant in affecting the dependent, you have to actually compare your t-test with CV, and then how do you want to find the CV? You have to go to the t-table. It will take some time. But by looking at the PV, well, in a second, you know that this variable is significant. A PV or p-value for a t-score is the probability of observing a t-score that size or larger if the null hypothesis were true. Okay, this is just the definition. Okay, so normally, of course, your software, your EViews will calculate the p-value automatically for every coefficient. So if you actually have collected your data, you have run your result, your estimation, you will see this PV. But if you haven't done it, you don't know where is the PV located. Okay? So be careful. Virtually every package report PV for two-sided hypothesis. So you have to check. If you are talking about one tail test, you have to adjust your PV because normally the software will give you the value of two-sided. Okay. Next, how do you use a PV to run a t-test? Okay. So let's look at the PV decision rule. Reject your H null if PV is smaller than level of significance. Remember what is the level of significance? What is it? I just mentioned to you just now.
Alpha.
Yes, thank you. It means that you are paying attention. So for the PV, okay, you always have to compare with the alpha. So if the PV is lower than alpha and you have the expected sign, you have to reject H null. If the PV is bigger than alpha, do not reject H null. So Somehow you have to remember this by heart. Okay? If you want to reject, do not reject the hash now. Well, but actually, if you look at the result generated from the e-views, it's already tell you by looking at the value. You don't really have to compare with the alpha. You know that which variable are significant or not. Okay? We will look at the examples of PV soon, even though you may have seen it in the previous discussion. Okay, examples of examples of t-test. There are 4 steps to conduct a t-test. First, you have to set up the null and alternate hypothesis. Of course, you have to. If you still remember the steps in statistics, you have how many steps if you want to conduct a hypothesis? Anyone? Oh, you don't remember, is it? So in statistics, you have 6 steps. Okay. Well, here they just give you a rough idea, but if you want to conduct the hypothesis testing properly, you have 6 steps. Okay. So let me just write down the steps. So the first one, you have to write down, state the null hypothesis. You have to write H null and HA or H1. Okay. So remember, HA is your own hypothesis. So you can come up with the HA first. Second, you have to write down the alpha. So what is the alpha? Is it 5%? Is it 1%? Is it whatever percent? So depends if what kind of alpha you want to choose. 3, sometimes alpha will be given in the question. So you don't really have to think hard. Number 3, this is your test statistics. So your test statistic, you're going to have a formula to compute your test statistic. You can have T, you can have Z, you can have F, you can have whatever test statistics. Okay, number 4, this is your CV. It will tell you the rejection region. Okay, then from the CV, you will draw a diagram. Okay, so if let's say your CV is here, and then your test statistic may be somewhere here, okay, you do not reject the hash now. Okay, so number 5, basically you will make a decision whether you want to reject or do not reject hash null. Number 6, this is the last steps. You have to interpret your result. So this is how you want to make sense of your statistical or econometric assumption here, a hypothesis. Because normally the hypothesis, you're going to put beta 1 or beta whatever p bigger than 0. And then beta p less or equal than 0. If you put it here, the normal people, the layman will not understand this. So the interpretation part will actually try to interpret what is your step number 1. Okay, so let's see. As I mentioned to you, this is the general steps. So you set up this hypothesis, choose the level of significance, and then your CV, you're going to find your CV. Okay, and then you run your regression because you're going to use your software, and you will get your T value, and then you apply your decision rule. Step number 4, very similar. Okay, and then you are going to compare your T value and CV so that you can decide whether you want to reject or do not reject the hash null. Okay, so next. So let's look at the example. You have, this is I think a new example. And this is for one-tail test or one-sided test. So this is the retail sales of new cars. So the sales of the car depends on the on what? Depends on the disposable income of people. When people have higher income, maybe the sales of the car will be higher, right? How about the price? When the price of the car is expensive, what happened to the sales of the car?
Lower.
Lower. So this is SUV. Do you know SUV car?
Yes, madam.
Okay, it's a big size car, right? It's a family car. So this is what we call a dummy variable. So it's 1 if let's say the car is SUV, 0 if the car is not SUV, or 0 otherwise. Okay, so somehow the expected sign is negative, as if like when the car is SUV, it has a negative impact on the cell. Perhaps many people do not like the SUV car. They like other types of car. Okay, so you have this kind of equation. So it says that step 1, you have to set the H null and HA. So you set up. The first one is positive. So beta 1 bigger than 0. Second is negative. Beta 2 less than 0. Third one is negative. Beta 3 less than 0. Okay. And the H null is just the opposite signs of your HA and it contain equal signs. Step 2. Choose your alpha and your CV. In this case, you choose 5%. Okay. So you have 5%. How do you want to find the CV? Your degree of freedom is 6. So let's look at the T table. So 5%, what is this? This is it one side? Let me see. I don't remember. Oh, one side. So this is one tail test. Your alpha is 5%. What is your degree of freedom just now?
6.
6. So 6. So 6 is here. Okay. Some students just simply take this. No. This is actually 10% for one tail test. You are looking at 5%. So the value is 1.943. This is your CV. Okay, so CV is a bit tedious because you have to go to the T table. But it's okay. This is just the process. And then you run the regression. And then you get the estimated T value. Okay, so you know how to compute the T value, right? We just learned how to compute the T value. Okay. Step 4, you want to apply the decision rule. You want to compare actually the T value with the CV. Okay, so beta 1, your, what is this? This is your T test. So beta 2, this is your T test. Beta 3, this is your T test. You want to compare with your CV. CV will be the same. In the first example, your T test is bigger than CV. And the sign of your T test is positive. So what will you say?
Reject.
Reject H null because your T test is actually larger than your CV. So if you wanna, let me put here. If you wanna draw here, because if you wanna compare the rejection region, it's better to draw a diagram. It's the middle. So where is the CV? CV is positive, right? So 1.943. So this is your rejection region. And then where is your T test? T statistic is 2.1. So 2.1 is bigger, or it is inside here. This is T test. So you have to reject because T is falling under rejection region. Okay. So beta 2, reject H null if your test statistic is larger than this. Of course, your test statistic is larger. But then, and if 2.8 is negative, your 2.8 is negative. Let me check. Is it negative 2.8? 2.8 is not negative. It's not negative. So what does it mean? Means that, let me draw here. What happened? Oh, it moved here. Okay, let me draw here. Oh, this is red color. Okay, so if you want to draw the diagram, this is 0. Okay, so reject H null if this is your test statistic. Okay, so your what is it?
CV.
Your CV. Your CV is 1.943. So this is your rejection region. Okay, but then your 2.8 is negative. Okay, reject H null if 2.8 bigger than 1.96 and if 2.8 is negative. Negative is this side, isn't it? Let me see. What is this? Okay. Now I got it. I was influenced with this value. T is 2.8, is positive. I was influenced with this coefficient. Okay. Okay. So basically, this is not right. Let me go back here. Where should I write? Okay, let me redraw the diagram. So this is 0. Okay, your CV is actually negative. Why is that? Okay, just to let you know, CV normally follow your hypothesis, the signs of your hypothesis. So what is the signs for the price? Remember, we said that when the price of the car is higher, what happened to the sales of the car? Negative, right? It will reduce the sales of the car. So the sign for the price is negative. So the CV, although the value of CV is actually 1.943, but because the CV sign follow your expected sign, which is negative. So CV should be on the left side. CV should be on the left side. So if your test statistics is actually somewhere in the left side, then you will reject your hash null. But if your test statistic on the right side, it is not your rejection region. Okay, so if you look at here, what is your test statistics for the price? For the price, the test statistic is positive 2.8. So where is positive 2.8? Is it in the rejection region? This is negative. So 2.8 perhaps somewhere here. This is your test statistics. So it is outside the rejection region. So what does it say? If it is outside the rejection region?
Do not reject hash null.
Yes, do not reject the hash null. Okay, so sometimes it's better to draw a diagram so that you can see the area. If let's say you just read the statement, you may get a bit lost. Okay, so the same thing with here, beta 3. What is beta 3? SUV, right? Reject hash null if this is the T score bigger than this area. And if this one is negative. Somehow this is negative, so you reject it. Okay, so let's look at the illustrations of these three outcomes. Oh, it's already there. Okay, so you can see here that, remember the second example, your CV is on the left side because the sign of your CV follow your HA, follow your expected sign. But then your test statistics is positive 2.8. So you can see that it is not inside the rejection region. Okay, so I hope, so basically the illustration is only 2 diagram. So I hope that you can also draw a diagram for the third beta. Okay, so far so good. Any question at the moment? Any question?
No, madam.
Okay. I'm thinking now it's slide number 30. We have until 48. Of course, we cannot finish today. Partly be blamed by the visitors just now. Can we have 5 more minutes, or you want to stop here and we continue in the next class? Any suggestion? You want to continue for 5 minutes, or you want to stop here?
Continue 5 minutes.
Oh, that's good. This is the spirits that I want to hear. Okay. Okay, so this is two-sided test. Well, the same thing. Two-sided test of whether an estimate coefficient is significantly different than 0. So when you have two-sided, basically they are testing these two tails simultaneously. Okay, so they are testing this tail simultaneously. Okay, two-sided test of whether an estimated coefficient is significantly different from a specific value. Depends. Significantly different from 0, significantly different from 5, 10, depends. Okay? Okay, so this is the examples of two-sided tests. Okay. So here because previously when I look at this example, I don't know what is this N. Then I put the footnote. N is the number of competitor. P is population. I is income. But I didn't realize that in the previous example they already mentioned. This example. Okay. So if you, remember you are testing two-sided tests. Okay, whether an estimated coefficient is statistically different from 0. Okay, so this is how you want to write down your hypothesis, HA, beta 1 or whatever beta. No, this is not 1. This is beta I, income. Not equals to 0. Beta I is equal to 0. So let me just give you a brief of background about this. Okay, so you have your equation, right? The number of competitors have a negative relationship with the sales of the restaurant, and then population has a positive impact on the sales of restaurant income. So somehow, some of you think that the income will have a positive impacts on the sales of the restaurant, right? But then, just in case, if you are not sure, is the income has a positive impacts or does it has a negative impact? So if let's say you are unsure about the sign of your independent variable towards the dependent variable, normally in econometric, we're gonna put two-tail test. We're gonna test beta 1 or beta whatever beta I not equals to 0 or equal to 0 because you're not sure whether it is bigger, it is smaller. If you're not sure about the sign, we're gonna use two-tail test. Okay? Okay, and sometimes this is another case. Sometimes in other study, when you do the literature review, some study found that the impact is positive, but in different study they found it negative. So now you get confused. Should I follow the positive or should I follow the negative? So in that case, because you're not sure, so what you're gonna do, you have to use two-tail test or two-sided test. Okay, so this is the same thing, right? We are going to the process, choose your alpha and CV. So using 5%, you can also try with the 1%, 10%, it's up to you. And then your degree of freedom is 29. 5%, 20, what is it? This is two-tail test, is it? Yeah. So now, two-tail test is somewhere here. And then your alpha is 5%. Okay, here. So your degree of freedom is 29. So from this highlighted one, go to 29. What is it? What is it, the value? 2 point... 29. 2.045. So you have to get 2.045. So if you are taking from the number from the table, you will have 3 decimal points. So don't try to round it up, just take the decimal as it is. Now you run the regression, you will get the t-value, you will get the standard error. And then now you apply the decision rule. Okay, reject your H0 if your t-score t-value bigger than your CV. Okay, in this case, you reject the null hypothesis. Okay, well, you reject, right? Because it is the t-score is bigger than your CV. Okay. Okay. Let me see. Where should I stop? Oh, maybe until the limitation. Okay. Okay. For a two-sided t-test with a specific non-zero coefficient value, the null and alternate hypothesis become okay. This is indicates that you don't have a what is it? You don't have zero value. Okay. So the estimated t-value. Remember how you want to compute your t-score before? You just have beta naught over standard error. But if let's say your beta for the H null is not 0, so what happened? That's why we put non-zero coefficient. Okay. This is how you wanna this is the formula, but then if let's say your beta for hash null is not 0, just put the value here and then you will compute your t-score. Okay, so decision rule will remain the same thing on how you want to find the previous decision rule. Limitations of t-test, of course, every test gonna have some limitation. First, t-test does not test theoretical validity. Remember, you will never test whether the theory is correct or not. You just want to confirm based on your sample, does it confirm the theory that you have learned? Okay. Okay. So in this case, you can see that the coefficients are statistically significant if you want to compute the t value and compare with the CV. Okay. The catch is that the p, where is the p just now? Is the consumer price index, and C is okay. So your P here, the dependent variable is the CPI, consumer price index, but they just put P. And C, the C here is the cumulative amounts of rainfall in the UK. So do you think that rainfall will have an impact on the CPI? It has no impact, right? Remember, this is the ridiculous variable. But somehow when you run it in using the regression, you found it significant. So it doesn't mean that using the t-test, it will actually test your theoretical validity. Okay, some variable, that's why you have to choose the right or relevant variable, because sometimes if you put nonsensical, irrelevant one, it may somehow turn to be significant, but it doesn't make sense. Okay. Second, t-test does not test importance. What does it mean? Now, you look at a t-score of 10. Where is t-score? So you have this t, if you can see my t, you have the first variable x1, the t-score is 10. The second variable, the t-score is 8. You cannot say that the t-score with the value of 10 is more important in affecting y compared to the t-score with the amounts of 8. Okay? You cannot say that x1 is more statistically significant compared to x2. So the result just tell you that, well, these two variables are statistically significant in affecting the changes in y. It doesn't tell that this variable is more important than the other. It doesn't tell you that. Okay? Last one, t-test is not intended for tests of the entire population. Of course, if you have the entire population, why should you actually have a sample? Okay, if you so t-test is only meant for testing your sample. You want to check whether your sample can actually represent, reflect, infer in or estimate the characteristic of your population. Okay, so it is not meant to test for population. It is only meant to help you to check whether your sample can infer your population. Okay. Well, I think this is confidence interval, another method apart from t-test. You can also use confidence interval. If you go to the t-test table, you will see confidence interval. For those who have taken statistics, I think confidence interval seems familiar to you, right? Okay. I will not skip this, because if I skip this, you will complain saying that you already forgot confidence interval. So we will be seeing confidence interval in the next class. Okay, will that be fine?
Sure,
Yeah,
sure.
madam.
So let me actually how to stop the recording. Stop recording.